Good morning, everyone. This is Craig. One of you wrote me yesterday and said you were having a problem with an ME problem, and I took a look at it, and I've got a video to show you. It was a stem and leaf diagram problem where you had to calculate standard deviation. So I've built a little workbook here, and you can see here are the values from the stem leaf diagram. These values will change, of course, depending on how many times you do this problem and which student you are. The numbers always change. What I've done is calculated my mean, and there it is, 9.6. And the formula, of course, shows up here in the function bar. And let's see, if I hit F2, I can also go into edit mode and escape to get out of edit mode. Yep, average of B4 to B13, that's my data. Okay, I also wanted the count of values, we need to know the number of values, so I used the count function. There it is, counting up those values. There's 10 of them. And let's see, what else did I do? Then I took the difference between the value and the value and the mean. And for each of these, you'll notice if you're watching the formula up here, it's $B, $15, which locks in that cell. That's what we want when I copy this first value down. Let's see, okay, so I got those differences, the deviations. Then I simply square the deviations. Again, the formula's in the formula bar there. Down to the bottom here, let's see, this cell, I sum up my squared deviations. There it is, using the sum function, D14 to D13. And then I make an equation to calculate standard deviation, and it's the square root of D17, the sum of the squared deviations, divided by B16 minus 1, and B16, of course, is my n value, but something's wrong. This is not what the standard deviation is given in the problem. But if I looked at this formula, I noticed that I made a mistake. Do you see the mistake in my formula right there? Whoopsie, didn't want to do that. I'll give you a couple seconds to look at that. It says I'm taking D17 divided by B16 minus 1. Well, it's an order of operations problem, and what I did is I'm telling Excel to take D17 divided by B16, take that division and subtract the answer of that from that division, subtracting 1. Yes, I need another pair of parentheses in here. I need to force it to do the n minus 1 first. And there I've got my answer that I wanted. And sure enough, it matches up. Here I used the STDEV.S function from Excel. And let's see, what's the argument? It's B14 to B16. Yep, I put that wrap that around my original data set, and I have the same two answers. Well, the student who wrote me said she saw this answer in Excel. That's what my spreadsheet I gave you that I distributed. And she said she rounded this value to 2.68, and it was wrong. That MML said the answer was 2.67. Well, here's what's going on. If I take this calculated value, no, I'm going to take both of these values at once, and I'm going to use this little button right here. This is to give me more precision button, increase the decimal. And if I click that a couple times, it's going to give me a couple more decimal places. And now look at the value. If you were to round this value to 2 decimal places, what would you do? Well, what's our rule? We want to round to the hundredths place. So we look at the 7, and then we look at the next digit after it, and it is a 4. And that means we do not round the 2.67 up to 2.68. The answer is 2.67 in MML. That is the correct answer. And Excel is giving that answer in both my longhand calculated version, doing all the work up here, or just using Excel's function. But you can see what Excel does is I decrease the number of decimal places from these. It goes down and it says, okay, there's 3 decimal places, but if I take one more off, I mean, it looks like Excel's going to round it, but Excel is smart. To 3 decimal places, it has rounded to 2.675. As it goes to 2, it stays at 2.67. It knows that it wasn't really 0.675, it was 0.67499. There's our answer, folks. Hope you enjoyed this fun-filled lesson.